Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Mark Barnes-Ryder. Monday night Q. Just by my colleague Mark Barnes-Ryder. Monday night Q. Good evening, Mark. How's your day been so far?
Yeah, hi Sam. Yeah, okay, thank you. For those that don't know, I work for the technical services team, and I've been looking primarily at contractors' assessment reports today, Sam. It's a sort of second check that we carry out to ensure that there's a good and consistent assessment process, so that our contractors are getting a good assessment.
Yeah, and I think it's one of the parts, isn't it? I think some of our contractors don't realise that we get audited on our auditing process, and that's coming up very soon. We'll have something like a 21-day audit by UCAS covering all parts of the assessment process. So yeah, that's one of the checks that we do as part of technical services when we're not answering the telephone and doing events like this.
Yeah, and technical emails, of course. So we answer a few of those, don't we?
Yeah. Okay, we'll start off with our question of the week, which was posted out across social media channels earlier today, and we'll go through our answer to that question. Then while you're putting your questions into the chat, which we please ask that you do, we'll go through some of the questions and answers that we didn't get round to from previous sessions. So please do start putting your questions into the chat as soon as you can, remembering that there's no such thing as a stupid question, only stupid answers. Please do remember to be respectful to each other within the chat, and because the whole idea of this evening is that collectively we help each other with the aim of improving our collective knowledge of and understanding of all things associated with BS 7671 and the world of electrical installation. So without any further ado, we'll have a look at this week's question of the week, which was every circuit shall be designed so that a small overload of which duration is unlikely to occur. And the options that we gave were, is it a 30-minute duration, a short duration, a long duration, or a finite 5 seconds? So every circuit shall be designed so that there's a small overload of which duration is unlikely to occur. And what's our thoughts and answer on that one, Mark?
So for those of you that answered a long duration, so BS 7671 permits overloads of short durations to protect the cables and the rest of the installation, but it doesn't like overloads of a long duration. So and regulation 433.1 provides additional information. The statement's actually in there, that 433.1. There is a definition of an over current or overload, and that is not due to any fault within the circuit. It's a healthy circuit, but for various reasons it could be have an overload condition. One of those is, a typical example is if you've got lots of current using equipment plugged onto an extension lead, for example. That's a common one, isn't it? And there's no actual definition in BS 7671 for a small overload, but further guidance, you can the device manufacturer, the overcurrent protected device manufacturer, can provide further guidance from the product standard. So depending on which devices you're using, you could get that information from the product standard.
Yeah, and so it's, I think the key thing is people sometimes get a little bit confused with thinking that an overload is a fault current due to a fault within the installation, and that's the thing that is made clear in the definitions in 7671, that an overload, as you said, is an overcurrent in a healthy circuit. So it's things like overloaded socket outlet circuits. Motor starters is another good example. So that's one where we know that during the starting phase it's likely to draw more current than under normal running conditions. So yeah, that's a good example, and it's a healthy circuit. It's something external. It could be a fault with a load that causes it, but it's not a fault within the installation.
No, we have to. We also have to remind our contractors and anybody else that's, for that matter, that's dialed in tonight, and thank you for that, is that, you know, your typical shower circuit, I mean, that wouldn't overload as long as the circuit's been designed properly. The only time that could possibly overload is if the shower's replaced for a bigger power output shower and the circuit hasn't been designed to take that additional power, so, or additional load. So yeah, your conventional fixed loads, they won't under normal conditions overload.
Okay, so yeah, please do put your questions into the chat. While we're waiting for some questions to appear, we'll just go back over some of the ones that we didn't cover in previous sessions. So first up, we've got a common question that comes into the helpline is, do all cables run in ceiling voids require the additional protection of a 30 milliamp RCD? So we know that 7671 specifies in a lot of instances that RCD protection, additional protection, is required for certain types of installations. But people often ask, if I'm running in that ceiling void, the void between one floor of the building and the ceiling of the next, if I'm running cables in that void, do they need RCD protection? The simple answer is no, not because of that location. So there's no specific requirement in 7671 to run to provide RCD protection for cables run in the ceiling void, and the reason for that is it's not perceived as the same risk of potentially being damaged by impact as cables that are buried in walls or partitions. So we know that if cables are buried in walls or partitions at a depth of less than 50 mil, then they need to be provided either with additional mechanical protection against impact or RCD protection. But it's not perceived as the same degree of risk when we're in that ceiling void. General rules still apply, so the cable has to be suitable for the environment it's being used in, or the way that we install it makes that cable suitable. And there may be other reasons why RCD protection is required. For example, it might be a circuit serving a bathroom, in which case then section 701 will tell us that we need RCD protection, or it might be a TT earthing arrangement, and in order to achieve our automatic disconnection we need RCD protection, but not just solely because of the cable being in a ceiling void. Would you add anything to that, Mark?
Yeah, that's a fair point, Sam. I mean, they're all fair points, well made, as you would sometimes say. But I mean, unless the client decides that they want those cables, you know, RCD protected, there's no other requirement. Or by another specification, for example, there is a regulation 110.1.3 that says that, you know, the regulations can be supplemented by the requirements or recommendations of other British or harmonised standards. So, you know, have a quick look at that reg, everybody. But as Sam says, ordinarily no requirement.
Yeah. Okay, another one is that in an existing domestic installation, are 16mm squared single core tails adequate if the rating of the distributor's cutout fuse is 100 amp? So again, something we come across a lot in domestic installations, where we've got 100 amp cutout fuse but 16mm squared tails rather than the 25mm. So is that acceptable in an existing installation, Mark?
Yeah, I think it could be. I mean, the key thing here is an assessment of the load. You know, the maximum demand, applying any sort of diversity factors. I mean, we used to see it, years ago with new builds where the DNOs had put 16mm tails on 100 amp cutouts, but they based it on their own criteria from the ENA, Energy Networks Association, based on the maximum demand at the time for that property. I mean, so it is, you need to make an assessment of that load under 132.16, taking account of any diversity. One of the things to bear in mind is if, for example, that was on a 3036 fuse, then you'd need to add that 0.725 factor to make sure that it wasn't, so for example, a 100 amp fuse is typically on a 3036 fuse would be about 72 amps. So you'd need to be aware of that. One of the other things is if the cable's been in service for a number of years, then you could look for signs of thermal damage, but it would be a good indicator if it's been in service for that long that and there's no signs of thermal damage that it would be okay. So that's often a good indicator. That's about it, I think. Yeah.
So it is one of those questions that we need more information, don't we, to answer it fully. But like you say, it is possible, providing we can confirm that those 16mm tails aren't going to be overloaded by the installation. Then, so we don't need the 100 amp fuse to provide overload protection. Then, providing it provides adequate fault protection, and the tails are sized large enough to carry that fault current till the 100 amp fuse disconnects, then it's possible. And we know, there are lots of installations out there on 16mm tails with smaller fuses, 60 amp, 80 amp fuses, and running perfectly fine. So if we can find out either through measurement or through calculation that they're not going to be overloaded, then it could be okay.
Yeah, I think the reg is the 433.3.1 reg, I think, from memory.
Yeah.
On that, yeah.
Okay. Another one from a previous session, and again, it's something that we get asked about, especially when people are retrofitting SPD devices into existing installations, is what size conductors should be used for the connection of a surge protection device. So as I say, we get asked this a lot with respect to retrofitting surge protection devices to existing installations, or when the existing installation is being added to or altered and the addition requires the installation of an SPD. There is actually a reg which gives us some guidance of minimum sizes. So if we were to look at reg, just let me pull the right reg up, 534.4.10, it gives us some advice on minimum sizes. So you can see that the minimum cross-sectional area for a type 2 SPD is no less than 6mm copper or equivalent, and for a type 1 is no less than 16mm copper or equivalent. And there's also some guidance with regards to regulation that we just talked about, 433.3.1, connecting the SPD to an overcurrent device, that the live conductors have to be rated to withstand the prospective short circuit current to be expected, and shall have a cross-sectional area not less than 2.5 mil for a type 2 and 6 mil for a type 1. So that's the first one for the cross-sectional area of the conductors from the SPD to the main earthing terminal, and then the second part are sizing for the live conductors between the SPD and its overcurrent protective device, if it's an external one. Some SPDs will be a packaged unit which they self-contain the overcurrent protective device, but others will require an additional independent overcurrent protective device, and that's where those minimum sizes are given in the second part of that reg. So there is some guidance. Also, as with everything, consider the manufacturer's instructions from the surge protective device provider, because there will give us guidance as well.
Yeah, the last time I installed one of those, I rang the manufacturer up and they told me what size protective device to use, which was compatible with their products. And it's also worth saying that, you know, we talk about copper equivalent, so 6 mil copper equivalent. So if you've got a conductor that's not made out of copper, it's got to meet, so for steel, for example, or aluminium, or, you know, whatever it might be, that it has to meet that 6 mil copper equivalent for that conductor. So for an aluminium, it could be a little bit bigger, couldn't it? 6 mil could be quite a bit bigger, in fact.
Okay, another one again that we get a common call is, what should I do when I find a TNCS system with a ZE that is much greater than 0.35 ohms? Again, common question that we get, and what's our advice on that situation, Mark?
I mean, the first thing I'd say is that the 0.35 that we're used to knowing is it's a value that the DNO use. It's not it is a typical value, but providing the ZS for that circuit is not greater than so that it affects the operation of the overcurrent protected device, it may still be okay. I mean, that's the crux of the matter. As long as the circuit impedance is within the limits for the protective device, you know, we'd recommend that. I mean, if it is, you know, reasonably high, then the DNO should be contacted, and we'd normally recommend that the electrician will speak to their customer, and they will generally ring up their electricity provider and kick it off from there. But if it's dangerous, the circuit impedance isn't within the permitted limits for that device, then that could make it more of an immediate dangerous situation. So inform the customer regardless. And the DNO, generally, they'll come out within 48 hours. If there's a genuinely high ZE, in my experience, they have got service level agreements to hit, and they'll generally come out within 48 hours to investigate further.
Yeah. I guess the other thing is, if you can tell them that it has deteriorated, so if you've got knowledge of a previous installation certificate or a previous condition report where it was a lower value, then that's good information to give them, because it's signs of a possible deterioration within the distribution or network. So yeah, that's a good point. But as you said right at the beginning, don't be surprised if it's slightly over 0.35 and they don't you know, rush to attend, because the 0.35 figure isn't a threshold that they have to meet. It's something that's given to enable you to do design. So before the TNCS system arrives, you can do your design based on a typical value of 0.35. So that's where that value comes from. But yeah, don't be surprised if they tell you that they don't have to achieve that, and so long as they've got a reasonable value and it's stable, they may not choose to do anything about a slightly different value from 0.35.
Yeah, and often, Sam, I mean, if it's a point, if the electrician's recording 0.36, 0.37, 0.38, they'll come out, and because they use different equipment, they might return a value of less than the 0.35 anyway, because they'll use an instrument that puts out a higher test current, and they'll be quite happy with that.
Yeah.
So yeah, I mean, you know, if you had a 0.45, a 0.5, then it's starting to get into the realms of high readings, isn't it? So as Sam says, it could well indicate a sort of latent defect or something that's, you know, breaking down under the road or whatever.
Yeah. But I think you hit the key point in that if it's a higher value but you're still achieving your ZSs of your protective devices, then it's something to note down, but it's not a concern because you've still got adequate fault protection. It's where that higher value takes you over the ZS, because now your R1 plus R2 hasn't changed, but the ZE has changed, so you're now over the maximum ZS. That's when it becomes an issue, and you need to work with the DNO to ensure that the installation's safe and compliant with 7671.
Yeah, and you know, this is where RCDs can help. So if you've got RCDs on the final circuits, I mean, we're not advocating that you say, oh, it's got an RCD on the circuit, that's fine, and walk away. We're certainly not saying that, but it can buy you some extra time for the DNO to come out and investigate and go from there. But certainly, if you think in realms of a TT installation where the RA value's high, a lot higher, isn't it? Typically, 25, 30, 40, even higher than that ohms, then it's a similar sort of scenario. So we're certainly not advocating that you just rely solely on the RCD.
Yeah. Okay. We'll take some questions from the chat. Please do put any questions that you've got tonight, any burning issues, questions that you've been rattling around thinking about for a long time. We'll have a go at trying to answer them. By all means, that's the whole purpose, and you may even get an answer from one of the other viewers within the chat. So yeah, please don't be afraid. Like I said, no such thing as a stupid question, only stupid answers. So let's have a look at some that have come in. So on a TT system, can a circuit breaker without RCD protection be installed if the loop value is within limits? The simple answer is yes, it can. You know, the regs do say that on a TT system, one or more of the following types of protective device should be used, the former being preferred, and it prefers an RCD, but an overcurrent protective device can be used, providing you can meet the ZS that we've been talking about. So you'd need to make sure that it's reliable and stable. But if I give you an example, if you've got a steel structured building where the constructional steel is forming a network of earth electrodes, you may get a sufficiently low value to enable you to be able to use a circuit breaker and still achieve its maximum ZS to provide disconnection in the required time. Now, that structural steel would be considered permanently and reliable, because unless they change the structure of the building, they're not going to change the way that the structural steel provides a nice earth fault path. So yes, it is possible, but you need to make sure that your overcurrent protective device has got a suitably low value of ZS, which is permanently and reliably insured. That's the wording that 7671 uses.
Yeah, and don't forget, there's actually a sentence or under table 41.1 that says that you can do that. And there's also note 1 that says disconnection may be required for other, not just electric shock, but for other purposes as well on that. So for protection against thermal effects, for example. So that's worth reading those notes underneath table 41.1, page 65. I'm looking at it now. So
yeah. Okay. Another one. Can I use an electrical installation condition report to record remedial work? What's our thoughts there, Mark?
Thanks for that one. Yeah, I mean, it is a common question. I mean, typically when I worked for a housing association, the remit for us was, well, if there was a broken socket in the installation, you could perhaps note it down that you'd replaced it at the time of the test, but we certainly don't recommend that for anything more than that, really, because they're two separate forms, aren't they? One's a report on the condition of an existing installation that's in service. And the installation certificate is for installation work. So, you need to try and not blur the lines so much. Just keep the lines nice and straightforward for yourself and the client. And we would say it's okay for perhaps one item of equipment, small accessory, but other than that, not really good practice.
Yeah. Okay. Another one. So when installing a double stack consumer unit, how do I comply with the requirements for all the RCBOs to be within 1350 and 1450 above the floor? So yeah, again, this is something that's becoming more and more frequent now with the with the division of installation and a lot of circuitry to provide intelligence and smart home functionality. We're finding far more circuits within a typical domestic installation now, and so people are going to double stacked boards where they've got effectively 2 rows of protective devices. I think plus add in the fact that also now you may have a separate RCD, you may have separate AFDDs, so we're sort of adding to the number of protective devices that are commonly used. And it is a situation then, because if we look at in England, the approved documents talk about the centre line of those switches being between 1350 and 1450 from the finished floor, and that height is slightly higher than normal switch to allow people to have access to it, but to perhaps take it out of the range of people inadvertently operating it, or maybe even children inadvertently operate it. So it's slightly higher than the 1.2. There is some guidance out there from our colleagues at BEMA, the British Electrotechnical and Allied Manufacturers Association, BEMA, who have said that when it is a dual stack board or dual height board, that they believe that it should be based around the bottom row of switches. So the bottom row of protective devices, that's what you should aim to get between 1350 and 1450 from the finished floor, knowingly that the other ones will be higher than that, but that again just moves that out of the reach of perhaps them being inadvertently operated. And do check as well, because the 1350, 1450 figures are for England. They're different in Wales, and just to make it interesting, different again in Scotland and different in Northern Ireland as well. So make sure that you comply with the correct document wherever you are in the UK.
Yeah, so for those working in the UK, the requirement's in document M, isn't it, for people with limited reach? But it is one way of complying with document M. They do mention that. There may be alternative ways. You'd have to speak to your building inspector if you're doing it to building regs. For a new build, for example, and the 1350 to 1450 is mentioned in document P. which is freely downloadable as well. So, but yeah, if in any doubts, then speak to your building inspector for new builds.
Yeah. Okay. We've got another good question that we often get asked. So, what is it that prevents me from putting a British standard circuit breaker from one manufacturer into another manufacturer's consumer unit? Isn't the British standard enough? Unfortunately not. So 7671, there is a regulation which I'll stop in a minute and we'll dig out, that says in our low voltage assemblies that, for example, consumer units, distribution boards, that the devices and the components shall only be those declared suitable according to the assembly manufacturer's instructions or literature. And it's all about component compatibility. So they will have been type tested to ensure that there's no detrimental effects of one device on another. And of course the manufacturer can only do those tests with their own products. So that's why it is. So I appreciate it does seem strange that you've got a British standard product but you can't use it in a different manufacturer's assembly.
Yeah, that's right, isn't it? They're type tested amongst other things for sort of the pollution grading, if you like, for want of a better word. I'm not sure if it's the 512.1.5 reg, Sam, for compatibility on 131. But the crux of the matter is that one manufacturer is not going to claim compatibility with another manufacturer's equipment. Although it's common that we do buy a separate enclosure, we buy a separate contactor, and then we buy a separate overcurrent protected device. And in some scenarios, that could be acceptable if they're all as long as they've got their standard. But generally, it's not good practice to do that, and you could invalidate the manufacturer's warranty on a large installation. That could cost a lot of money, couldn't it?
Yeah, I'm looking at, I just dug it out while we were talking there. So I'm looking at 536.4.203 on page 183, and it says in low voltage assemblies to BSEN 61439 series, e.g. consumer units, distribution boards, incorporated devices and components shall only be those declared suitable to the assembly manufacturer's instructions or literature. So there it is. That's what we always refer people to. So for compliance with 7671, you have to meet that reg. And as Mark says, if you get an assembly which you manufacture, so you've got an adaptable box and you're putting things in, you then become the designer of that box. And are responsible then for ensuring that there are no compatibility issues with the equipment which you install in it. So that's something to bear in mind as well. But it is a common question which comes up, and everybody says, why don't we just get all the manufacturers together and get them to agree that if you meet the British standard, and that sounds great, but it's not as simple as that, because the manufacturers will say that they've only type tested their own equipment. So it's an issue that we know of, and daily we see photographs where people have got multiple different manufacturers in the same board. There's no obvious signs of issues, but what we can say is that's not compliant with 7671.
Yeah, they don't always fit either. I've seen, front covers on disc boards where you've got the IP rating's been compromised, where it's been cut out to make that device fit, and sometimes the toggles don't work the same way around, and that can be really confusing and quite dangerous actually on certain types of installations. But the reg that Sam's mentioned has got a .203 at the end of it, so it's an English reg, it's an English requirement. Not sure if it's a requirement in other countries, but certainly here in the UK it is.
That's a good point, actually, Mark. That I've never thought. Is that the same in other countries? Because it'd be interesting to have a look at the European document that's based on, to see why is it a UK only reg.
Yeah, quite. Yeah.
A couple of comments that have just come in that I just want to say. So one engineer has said, going back to the 1350/1450 consumer unit height, if a customer doesn't want it at that height, is it as simple as recording it as a departure? Well, no, because it's not a BS 7671 departure, it's a building regulations departure. So it would really be down to the building inspector, and our experience tells us that they won't accept anything else other than that guidance which is in the approved document. But if you were in a situation where the customer was adamant, then I would suggest speaking to building control, explaining the situation and getting some documented advice from them, which you can then share with your customer. Because as I say, it's not a 7671 requirement, it's a building regulation requirement. And another engineer has said, I do new installations including consumer units. Different companies make PV and air source heat pumps installation certificate. How can I properly note this in my installation certificate? So different company make PV and air source heat pump installation and certificate. So I'm not sure on your question there. If you're saying that they provide their own equipment, their own consumer unit, for example, that can be different manufacturers' equipment in different parts of the installation. What we're referring to is trying to put different devices, different protective devices in the same manufacturer's enclosure. So you could have manufacturer A providing a consumer unit for PV and manufacturer B providing a small consumer unit for heat pump installation, and that could be certificated as being compliant with 7671. What we're referring to is the 7671 requirement that all integrated devices within a single assembly are from the same manufacturer.
Yeah, and I think the part of the question was, how does he record it possibly? As I say, the information's a bit sketchy there, isn't it? But it boils down to being explicit in the description of the work that you've carried out. Now, whether that you can fit that in the little box on a certificate, or you add it as an additional note if you're doing electronic certification. But so often we see certificates in customer relations that have come through for us to review, and there just isn't enough information as to the actual work that's been carried out. And equally, you can also list the work that isn't part of your installation. There's no problems in that. Sometimes that can be a whole page worth, but it's worth noting it down if that's indeed is your question.
Yeah, no, it's a good point, and use that section that says comments on existing installation, because if that was already there, installed by others, you might want to document that fact that it's not something you've done, it's something that was there already.
Yeah.
Okay, we'll take one last one. When carrying out electrical work on an installation forming part of a TNCS system, is it necessary to upgrade existing 6mm protective equipotential bonding to 10mm? Again, common question, because previously a requirement was based around 6mm bonding conductors. That was increased, and a lot of existing installations out there are still running with 6mm bonding conductors. Long story short, in the answer, is it necessary to replace them? No, not necessarily. So there's some good guidance out there that if the existing 6mm conductors do connect all of the extraneous conductive parts, so everything that needs bonding is bonding, and they've been in place for a significant amount of time and they're not showing any signs of thermal damage, then it's not a requirement to upgrade the bonding. If you were installing any new bonding because there were new extraneous conductive parts or you were working in a new area, then your new bonding would need to be compliant with 7671 current version, and that would tell you that the minimum bond would be 10 mil. So you could consider upgrading the existing send mill, but it would only be a consideration, not a requirement. And again, we just mentioned it, this would be one of those key details to record in your certificate in the box on existing installation section, to make it clear that bonding already existed. You did everything reasonably practical to confirm its adequacy by visually inspecting it, and perhaps putting a clamp meter around to see if there were any circulating currents in the bonding conductors, so that you can then document that you've confirmed its adequacy for continued use.
Yeah, and just, using words such as no signs of thermal damage to existing bonding. I mean, just those few words there tell somebody else that's electrically competent that might be reviewing that certificate, tells them an awful lot that bonding, has been checked and there's no signs of thermal damage, because that's the key thing for us, isn't it? If there's signs of overheating or whatever, then a fault has already occurred, possibly. And just, if you are going to clamp meter that bonding, it's not unusual to have some value of earth leakage or circulating current on that bonding conductor. So don't get too excited if you do find, when you're measuring, that there is a small amount of circulating current.
But again, it's a great point that, if you make the decision not to upgrade it, it's worth recording why, and like you say, by you confirmed through visual inspection that there was no signs of thermal damage to existing 6mm bonding. So and then that makes it clear that it's not just something you've overlooked, but you've made an engineering judgment as to why you haven't upgraded it, and then you've documented that engineering judgment. That's really good advice to take. Okay, once again we've shot through our 45 minutes. Just before we disappear, I want to make you aware of a few things. So we've got some more editions of our webinar series, The Wire, coming up. Next week we have one covering electrical energy storage systems, and that's on the 14th of November, and then towards the end of November, on the 28th, we've got a session about common mistakes on NICIC assessments and how to avoid them. So that's something that we've been asked to put on, and hopefully you'll find that useful. And then there's one more, we've got our end of year technical quiz on the 5th of December. Always proves pretty popular, and a little bit of a light-hearted way to end the year as well. So if you're interested in any of those, please go on to the NIC website and register your intention to attend those webinars. Also want to make you aware of something that we've started. So there's an NIC EIC Installation of the Month competition for November, which ends on the 23rd of November, so it'll be running for just roughly 3 weeks. There's lots of information. This one's only open to NICIC certified businesses. If you go onto the website and look in the section for Installation of the Month, there's lots of advice about how you enter the competition. The prizes, including a training package worth over £1,000 to the winner of the monthly competition, along with getting a lot more exposure and invites onto our social media topics. So something that we've just recently launched, so please you know, if you've done something that you that you think is a bit different, a bit novel, and something that you'd like to promote, then please go onto the website, share us the story of that installation along with some good valid technical pictures of it. So please do go to the website and have a look, and look out for there'll be more coming across on social media about that installation competition. Please do stay in touch. We've got lots of different mediums, X, Facebook, LinkedIn, YouTube, Instagram, that we post out on, and we love to hear back from yourselves as well, even with questions. So if you've got questions that you want us to answer in a future session, a future Q&A session, then please let us know what they are. And talking about that, there is the last one. So we do these Monday night Q&As on the first Monday of every month. So there'll be one more towards the end of the year on the 2nd of December. So if you've enjoyed this tonight, or perhaps you're watching this on demand and would like to take part live, then put that date in your diary for the next Monday night Q&A session, Monday the 2nd of December, kicking off again at 8 o'clock in the evening. So how's that gone for you then, Mark? Again, it's always the quickest 45 minutes of my month every time. How's it been for you?
Yeah, same here, Sam. Same here. But we've had some interesting questions, and hopefully we've managed to, you know, give a bit of industry guidance there to everyone that's dialed in. And yeah, it's all about helping to improve the industry as a whole, isn't it? So that's what our aim is. But yeah, it's absolutely flown by. It's absolutely flown by for me. But always good to have some of those questions coming in.
Yeah, no, it's good. Well, I think sometimes we if you get more than two people talking, we could stay all night. But yeah, it's always good. All right, well, thanks very much, and thank you very much for those participating that put your questions in. I do apologise if we didn't get round to answering your question tonight, but then what we'll try and do is use that as the intro to the next session. And by all means, if you've got a question that you do want us to ask, then either come along on Monday the 2nd of December, or post the question to us through one of the social media channels. Without any more, thanks very much for your time.
Cheers.